Hello everyone. Today we will discuss the topic is hierarchical clustering. It's come under the module of unsupervised learning. Already you know the unsupervised learning. It is the type of machine learning. This learning is like giving a machine a file of unrecognized items and asking is it to group them or find relationship on its own. So it is the unsupervised learning. These algorithm categories the two types. One is the clustering algorithm, another one is the dimensionality reductions. So the hierarchical clustering is the one type of clustering algorithm in unsupervised learnings. So here it is another unsupervised machine learning algorithm. Already know the k-means algorithms. So here which is used to group the unlabeled dataset into a cluster and also known as a hierarchical cluster analysis. From this algorithm, here develop the hierarchy of cluster in the form of a tree. So this tree-shaped structure is known as the dendrogram. So first see the hierarchical clustering techniques have two approaches. One is the agglomerative, another one is the divisive. So first we see the agglomerative. It is the bottom-up approach. So in which the algorithm starts with taking all data points as a single clusters and then merging them until one cluster is left. So that is the follow of the bottom of approaches. So second type is divisive algorithm. It is the reverse of the agglomerative algorithm, as like it is a top down approaches. Now we see the why we are going for the hierarchy clusterings. So here in the k-means clustering that there are some challenges with this algorithm which are predetermined number of clusters and is always tries to create the clusters of the same size. These challenges will facing in the k-means algorithms. So to solve these two challenges, we can opt for the hierarchical clustering algorithm because in this algorithm, we do not need to have a knowledge about the predefined number of clusters. So it is the one advantages in the hierarchical clustering. So first we see the agglomerative hierarchical clustering. Here it is a popular example of hierarchical clustering algorithm to group the dataset into a clusters. The clusters is based on the same or similar features. It follows the bottom-up approach. It means this algorithm consider each dataset as a single cluster at the beginning and then start combining the closest pair of the cluster together. So next it does this until all the clusters are merged into a single cluster that contains all the dataset. Here see the working of the agglomerative hierarchical clustering algorithm. Here the hierarchy of cluster is represented in the form of the dendrogram. This diagram is represent the dendrogram structure. Here create each data point as a single cluster. So it's here three type of data sets, three different colors as a data points data set. Let's say there are a n data points. So the number of clusters will also be a n. The next step, take two closest data points or clusters and merge them to form one clusters. So there will now be n minus 1 clusters. So again, take the two closest clusters and merge them together to form a single clusters. There will be a n minus 2 clusters. The first figure is represented by n minus 1 clusters. The next one is represent the n minus 2 clusters. Next, repeat the step 3 until only one cluster left. So we will get the following clusters in the every steps. So finally, we will get one clusters. Once all the clusters are combined into a one big cluster, develop the dendrogram to divide the cluster as per the problems. It is based on our dataset in real-time applications. Next, we will find the distance. Here, the lot of distance method is followed. Here, mostly use the Euclidean distance. So, measure from the distance between two clusters. The closest distance between the two clusters is crucial for the hierarchical clusterings. There are various ways to calculate the distance between two clusters, and these ways decide the rule for clusterings. These measures are called linkage methods. Here we consider the 3 to 4 methods in the linkage methods. The first one is the single linkage method. It is the shortest distance between the closest point of the clusters. Here consider the below figure. It is an example of single linkage. We have two types of cluster, two types of data points. It is connected to the single linkage. The next one is the complete linkage. It is the furthest distance between the 2 points of two different clusters. It is one of the popular linkage methods as it forms tighter cluster than a single cluster. Next, the third one is the average linkage. The average linkage method in which the distance between each pair of dataset is added up and then divided by the total number of datasets, then to calculate the average distance between two clusters. So it is also one of the most popular linkage methods in the hierarchical clusterings. Next, the centroid linkage. Here we consider the linkage method in which the distance between the centroid of the clusters it is calculated. So it's the one examples for the centroid linkage. We have two data set or two clusters. Here we consider and create the centroid of the clusters. So here also one centroid is formed. The second data set also to create the one centroid of the clusters. Next, the dendrogram in hierarchical clusterings. The dendrogram is a tree-like structure that is mainly used to store each step as a memory that the hierarchy clustering algorithm performs. It's plot the y-axis show the distance. Here we are used the Euclidean distance method between the data points. And the x-axis shows all the data points of the given data set. So we have the two type of graphs is available. The one is the data points based on the linkage methods. So the second one is the represent the dendrogram structures. It is like the tree structures. So the same y-axis consider the Euclidean distance like 0 to 5, 10 up to 25 distance. The bottom is represented by the our number of data points like P1 to up to P6. We consider the 6 data points. Here it's showing the how clusters are created and agglomerative clustering, and the right part is showing the corresponding dendrogram. As we discussed the above, firstly with the data points P2 and P3 combine together and form a cluster. See the diagram. So P2 and P3 first is combined, merge these two one, then create the next combine with the next cluster. So corresponding a dendrogram is created which connected to P2 and P3 with a rectangular shape. So the height is decided according to the Euclidean distance between the data points. So the height is depend on the Euclidean distance. So next one, in the next step, point 5 and 6 form a cluster and a corresponding dendrogram is created. So it is higher than of previous as Euclidean distance between P5 and P6. It is little bit greater than the P2 and P3. Here see the distance between P2, P3 cluster and the P5 and P6. It has some highest distance to in the P5 and P6. Again, two new dendrograms are created that combine the P1, P2 and P3 in the one dendrograms, as well as P4, P5 and P6 is the another dendrogram. So at last, the final dendrogram is created that combines all the data points together. So see the diagram. The first group is the P2, P3. It is based on the Euclidean distance. Second, P5 and P6 is merged. Then P5, P6 is combined with 0.4. Similarly, P2, P3 is combined with 0.1. So see the distance of these data points. And finally, we merge the P1, P2, P3 to P4, P5, P6. Is finally we consider the single clusters. These are the references. Thank you.